Hello, we are group number 14 and my name is Mereke. I am system manager.
Hello, my name is Askar and I am a network engineer.
Hello, my name is Zharas. My role is analytic.
So, as a system manager, I made an action plan and I made a presentation. So, we're using Narxoz schablon and wrote our group and the teacher. Also, this presentation at first is introduction, is a chosen topic. It's Narxoz University and information about us, who is who, network engineer, system manager, and analytic. So it's a lecture reviews. What link we take it in for doing this packet tracer, and also project objects and aims. We can watch all business and technical goals in a table. We given all information, and then engineer will tell you all this information in details, and also taken terminals and our packet tracers.
As a network engineer, I started to come up with a network topology diagram, how it should look so that everything looks neat and reliable. To do this, I asked an analyst for help. Having found a couple of examples of neat network topologies from the internet, he offered several options. And together we combined all the best sides of different examples and came up with this network design. Good. Now I propose to analyze each step in turn. To begin with, I installed the first router. It will be a key element in our network. I also installed 3 L3 switches for different parts of the networks. The first part will consist of the main staff of the university: administration, president, accounting, and library. On the left side is the dean's office, or rather several floors with their own dinners of the schools. Well, the right part is a general view of the university classrooms, because there's no point in creating a bunch of identical rooms. There's a server room at the top. It's intended for the general configuration of our network, in our case FTP and NTP. And so, after adding the rest of the intermediate end devices, I started connecting cables via interfaces. After these machinations, VLAN groups are created to isolate group traffic in the organization, which simplifies network management and improves network performance as well as enhancing network security. I created separate VLANs for each staff and a common VLAN for the classroom. I created a total of 10 groups, so having configured the sub-interfaces and switched the switches to trunk mode, I finished configuring VLAN groups and inter-VLAN. You can make sure of it by pinging any computer in another VLAN. As you might have noticed, the IP addresses of the endpoint devices were handed out using a DHCP server. I propose to discuss its operation in detail. Perhaps setting up DHCP was the most difficult part of working in Packet Tracer. The initial idea was to put a separate server for its distribution, but because of that a lot of problems appeared. Either routers refused to send message between computers and the server, or the server itself refused to accept the request of computers to give out IP addresses. Because of all these numerous errors, I decided to take the easier route and configure the main router as a DHCP server. Of course, using the router as a DHCP server is not as efficient as setting up a separate server, but I think it's enough for the overall network layout. Alright, DHCP has been taken care of. There's just a couple of little things left to do. Let's start with FTP and NTP. To save space and money, I configured both protocols into one server. Surprisingly, everything worked almost perfectly. Servers and computers were able to communicate without any problems, and I didn't have to get depressed anymore. Let's check their work. First, FTP. Go to any computer and type this command. As we can see, everything works. To check NTP, just go into the router and ask for the clock details. It works fine too. The next step is to configure the static route. This is done simply. Go to each of our routers, click on static and specify the network, subnet mask and IP addresses of the next hop. STP. I didn't make it. Let me explain. At first I had no idea what it was, but after reading I realized that it's a kind of hierarchical tree structure where there's a root and children. But STP is only used on switches or devices running at layer 2. And if I had a network with extra connections, STP will be important to prevent problems. But in my case, all switches are connected to a single layer 3 switch and there's no extra connectivity between them. So I decided that the tree structure is unnecessary in my network. I configured SSH and Telnet the same way on the main router as DHCP. Honestly, I didn't see much point in configuring Telnet, but since Telnet can be configured quickly in a couple of lines, I added it as well. And so, all computers successfully connect to both Telnet and SSH. You can check this. As for network design principles and troubleshooting, I think I've got that one covered as well. I don't know about professionals, but it looked beautiful to me. Great, my time has come. Let's listen our analyst.
Thank you, dear colleagues. As the analyst on this project, I would like to present the work I have completed and provide details on the devices added from Packet Tracer. Firstly, we have the following network devices. For example, main switches, 2 units. Multi-layer switches, 3 units. Regular switches, 11 units. Additionally, the following end devices were included: personal computer, 13 units. Printers, 9 units. Phones and laptops were not included in this analysis as they were used for experimental tasks. I have organized all the devices in an Excel table, where I specified quantity, device name, cost, total cost, and review. To enhance clarity, I added images of the devices sourced from the websites where they are sold. To make the analysis process more convenient, I coded this table in HTML. Now, we have a clear and user-friendly table, containing links to vendor websites, accurate names, and the prices of each device. I look forward to presenting this table to you and discussing all the details during the project defense. Thank you for your attention and see you soon.